Differential equations, type 2, real world. D, nonlinear motion. In 2013, we had an A, a B and a C in the question. And part C was given to us as water flowing from a tank at a rate that is proportional to the volume of water remaining in the tank. And we're told that the tank is initially full and after 1 hour it is half full. And we're asked after how many more minutes will it be 1/5 full. So we're not given any equation here, so that's the starting point that we have to actually work out what the equation is. So we're given a rate that is proportional to the volume of water. So what we want to do is basically we're looking at water in a tank and it is basically decreasing in volume. So therefore, if we say V is equal to the volume of water in the tank, then basically what we're having is the rate of change of the volume with respect to time is directly proportional to the volume of water remaining in the tank. Now the volume of water in the tank is basically decreasing. So if I go from proportional to equals, we always end up with a constant of proportionality, and that is going to be negative because it is decreasing. Okay, so therefore, or if I put in the minus there even, if we're looking at our limits given to us in the question, well, what do we know at the start? What do we know at the end? Well, at the start, the tank is full, so therefore our volume is going to be the maximum possible volume, starting at 0 seconds. At the end, we're told that it is half full, so it's going to be half the original volume. And the time is 1 hour, we're told here. So therefore, our time is going to be in hours. So if I rearrange my equation here, I'll end up with 1 over V dV is equal to minus K dt. And if I put in my limits, my upper limit is 1, my lower limit, my upper limit is a half times V, and my lower limit is V. And my upper limit is 1, my lower limit is 0. So I have 1 over a linear function. So therefore, if I integrate 1 over a linear function, we know that it is natural log. So that's going to become the natural log of V within the limits of V over 2, or half V, and V. And that's equal to minus K times T within the limits of 1 and 0. So if I sub in, I have natural log of V over 2 minus natural log of V. So upper limit minus lower limit is equal to minus K. And if I'm subtracting my logs, that means I know from page 21 in my maths tables that when I have log x minus log y, that's equal to log x over y. So in other words, if this is x and this is our y, that's going to become natural log of V over 2 divided by V is equal to minus K. Actually, I'm just going to go back there and I'm going to actually multiply everything across by minus 1 first. It's easier. So I'll just get rid of that x and the y there. Okay, so multiply across by minus 1 there because we're looking for K on its own. So we have K is equal to natural log of V minus natural log of V over 2. Okay, before I apply my log rule. Okay, and now I have natural log of V divided by V over 2. And of course, if I'm dividing by a fraction, I turn it upside down and multiply, which just gives me natural log of 2. So now we know what K is. And there was 5 marks going for that. Okay, so if we go back, we now have after how many more minutes will it be 1/5 full. So 1/5 full means our limit has changed. So we need to start again. So we're going to go back here to the next page. And we have basically our function at the start and at the end. Well, at the start we have a full tank, and at the end this time we're going to have 1/5 full, and we want to know when does that happen. So again, we have 1 over v dv, upper limits 1/5 of v, lower limits v, and that's minus k dt, and upper limit is t and lower limit is 0. But of course k we now know is natural log of 2. So now we just integrate as normal, or you could of course go to this part of your previous answer and just sub in your new limits, because the integration is still obviously going to be the same. So if I integrate 1 over v, it's just natural log of v as we saw already. This time my upper limit has changed, and my constant has been found, so it's natural log of 2 times t. So that's natural log of v over 5 minus natural log of v is equal to minus natural log of 2t. And again, if I rearrange the equation, we want to get t in its own. So that's going to be natural log of 2t is equal to natural log of v minus natural log of v over 5. And again, we know, as we said on the previous page, that when we have two logs, same base, we use our maths tables, page 21, for our log rules. So we have log x minus log y equals log x over y. And therefore that's natural log of 2t is equal to natural log of v over 5. And again, if I'm dividing by a fraction, I turn it upside down and multiply. So that just gives me natural log of 5. So therefore t will just be natural log of 5 divided by natural log of 2. And therefore the time is 2.32 hours. But we have to be careful, because that's not what the question asked us. It didn't ask us when is it 1/5 full. It says how many more, if we go back, how many minutes. Sorry, I keep deleting that. So how many more and minutes. So more meaning the difference. So it was 1 hour when it was half full, and we want to know when is it now 1/5 full. So it took an hour to get to half full, and therefore if I get the difference, so 2.32 minus an hour, then that gives us our time is 1.32 hours more. But of course in minutes, well, we have 60 minutes in an hour, and therefore that's going to give us 0.32 times 60 plus 60, which is 79.2 minutes more. Okay, so we had 5 for getting to this point here, and then 5 for getting our answer overall. So we had 5, 10, 15, so we had 20 marks for that part of the question. So we had 5 for getting here as well. Sorry, I forgot to put that in. So we had 5, 10, 15, so 20 marks total. So a nice little question that, but of course if you don't know how to set up the equation to begin with, you can run into all sorts of problems. So you really need to be able to read the rate of proportion and what does that mean, and also is it increasing or is it decreasing. So if it's increasing, it would be a positive rate of change, where if it's decreasing, it's a negative rate of change.